Hi everyone, thank you for listening to our presentation of the paper Process Data First Exploration. If you see this, it means that we have some technical problems, so apologies for that. I'm Antonio Martini. I'm associate professor at the University of Oslo, and we wrote this paper together with Therese Besker and Jan Bosch, who works at Chalmers University of Technology. So first of all, why bothering with process that? Let's try to explain a little bit about that. Like everything else in software development, process improvements needs to be prioritized with respect to other issues, right? So we have a backlog, we have a limited time to for our teams to work, and we have a bunch of things that we would like to be prioritized and to be carried out. But we can have bug fixes, features, technical debt, process improvement, social issues. We can have a host of different things, but we have only a few slots that are available for what we do next sprint, for example. So how do we prioritize this? Different people do prioritize in different ways. It's in general, it's very difficult to prioritize everything. So some of these things just gets down prioritized. We know that technical debt is generated by this down prioritization. So technical issues are down prioritized. They are not taken care during development. And then what happens is that we have costly consequences, or else the interest of the technical debt. The question here is, are process improvements also down prioritized? I mean, we know that there are a lot of possibilities for improving our process, but does it actually happen? How is that prioritized with respect to other activities like feature development, bug fix, technical debt, and so on? And then, if that happens, is there such a thing as process debt, like there is technical debt? So that's our first, question from point of view, because technical debt has been definitely studied during the last 10 years quite a lot, extensively, but I haven't seen that much on process debt personally, and we don't find that much in literature. So maybe this is something that we need to take care of in research. So just a quick recap on why we use a financial metaphor for software development. We know that is the suboptimal solution, and then the problem is that everyone needs to know the interest on that debt, right? If you have a loan, you want to know how much interest you're paying every month. Otherwise, that could be very problematic if you have high interest to pay. So we think about software in business terms. That's the idea. Same for technical things and for process. So the idea is that we have a process issue or a technical issue. In case of technical debt, it works the same way. We try to think about it as a debt. We try to understand and estimate and communicate and calculate and the interest or the consequence of that debt. Then we can try to take budget decisions on what to prioritize. Should we repay this debt or not? So that's what's behind, right? And a concrete example of process debt, because maybe otherwise we keep it too abstract, can be the lack of synchronization between agile process and a certification process. So this is something that we have seen in some of the companies that we work with. We can have an agile process, which is, for example, it has a continuous delivery process. So the developers, the teams, they just push out new features every day or something like that. And then this can also be like an environment. We have a heavy certification process where we need a lot of documentation up to one point in time. If these two processes are not well synchronized, what happens is that the teams might be very taking like a surprise, and they have continuous delivered features, but they haven't had the documentation needed for the certification. And at some point, you just have this big documentation need, and what happens? It's a big disruption. There are a lot of consequences, confusion on both parts, lack of important documentation, and that can be translated in money sometimes, and also the teams lose the flexibility. They cannot deliver it continuously anymore, but they have to just stop all this documentation. So this is an example of a process debt. So what are our research questions? Research questions are, how can process debt be defined? What types of process debt do actually exist? How is process debt accumulated? We want to know what happens. What are the causes? What are the consequences? And what similarities and differences there are between process debt and technical debt. Why is that? Because as I mentioned, technical debt has been already studied to some extent at least. So maybe we can use some of the techniques that the technical debt community is offering to tackle the process debt. A few words about the study design. We had 3 phases. First, we had a workshop, a preliminary workshop to understand better what if this study could be, of interest for the companies, and to understand what they if they thought that this process debt was like an interesting topic to research. Then we had some qualitative data collections in which we have both semi-structured interviews. We actually had also unstructured interviews, and we actually look at some documents of processes and so on. We have analysis and synthesis, and we try to build an explanation from all these documents and the interviews that we collected. We had 4 large companies and 16 participants in this first study. We have open-ended questions. We want to be as exploratory as possible because we don't know much about process debt. So we use semi-structured and even unstructured interviews to just let them talk about examples of process debt. And we look at process document. We just put all these things together. In a data analysis, which we use, as I said, explanation building, and we build this large sort of mind map in which we have different all the concepts were coded in a, like you could think about open coding from grounded theory. We use a similar process, and then we try to connect all these concepts all together and try to make sense of them. And let's talk a little bit about the results, which I think everyone is interested in. So first of all, we start with the types of debt. What types of debt we found? The first interesting thing here is we think that, so process is defined by several activities. It can be like, there'll be like a host of different activities that can be suboptimal. So for each of those activities, you probably want to identify a different type of debt. Although for technical debt, you have like very static categories, architecture, code, and so on and so forth. This in process debt, you might want to have this activity-based debt because it works in a bit different way. Then we found that there are roles debt. Roles are important in the process. Documentation, you want to document the process, and there might be a problem there. As I mentioned before, the processes might not be well synchronized. Process might be wrong for the for the purpose. And interesting enough was that infrastructure is something that supports the process. Like if you think about project management tools and other kind of tools, there's a lot of infrastructure to support the process that would not be useful if it wasn't for the process. So infrastructure is a part of actually the process. And if that doesn't work, the whole process doesn't work. So that's why we think that infrastructure is part of the process, should be part of process debt. There are a lot of causes, and I don't have time to go through all of them. So I will just mention a few that are maybe more interesting. One interesting here was like value neglection. If you don't know what the value of the process is as a stakeholder or as someone who need to execute the process, it's very difficult to justify why I should just do some extra effort to implement the process. So this value neglection is one of the main causes for causing process debt. There are a lot of other things. We found a lot of cultural factors. Actually, I think cultural factors account for, someone said even 50% of the process debt. It was a rough estimation, but cultural factors are actually quite a lot, which in the end can be like, due to experience, maturity, motivation, leadership styles, but there are quite a lot. So I would recommend to just look in the paper. Among others, also organizational factors, we found quite a few. And in the end, external trends was also interesting, which means that you might have external trends that, promote using new processes that not necessarily fit your organization. We found a lot of consequences, and we found both long-term and initial waste. That's a bit different from technical debt. Initial waste is usually not that much into, we cannot find that much into technical debt. So whenever you create a process, you might already have an initial waste for developers. And as the technical debt, we can have like long-term consequences. And some of them are actually interesting because we can see that many of the participants realize that process debt can actually create technical debt. So technical debt is created by process debt. An interesting thing here is that the initial waste, if overlooked, can actually become long-term consequence. So process debt, to try to understand what is process debt altogether. We know that we have stakeholders that can, they try to create, they give input to create an optimal process, hopefully. But we found these three patterns for accumulation of technical or process debt. There is a divergent from an optimal process, a formal optimal process. We can, on the other hand, we can have like the actual process is not well defined, and then you can have suboptimal infrastructure, as we mentioned before. We have a lot of causes, like I showed. We also have different initiators for the suboptimality accumulation patterns. It can be a process designer who doesn't design the process well. It can be a process executor who just, diverge from the optimal process. It can be the actual infrastructure. Process that causes consequences that affect stakeholders, as we mentioned. And then process that can have different types, which depends on suboptimal activity and also different aspects that I showed before. As interesting is that process that can be assessed by three variables, two of which we already know from technical debt: the cost of change, which can be considered the principal, and the negative effect, which can be considered the interest of the debt, so how much we have to pay extra. And this can be sort of measured by understanding the consequence. One third thing that I think is quite interesting, like we discussed before, value for stakeholders. It's a new important variable. For technical debt, the value of the code is pretty obvious because you need to deliver code to the customers. But here, the process, the value of the process is not obvious. So you can actually do code without that specific process. So how much value has that process, right? Understanding that value for the stakeholders and its evolution is actually quite important to assess the process debt here. And hopefully this leads to a better prioritization of the process improvements. We also have a new definition for updated process definition for process debt. Is the occurrence of, so this is similar for the technical debt. What we changed in the end with this study was replacing what the debt is, which is a process design. It's a diversion from the non-optimal former process or in the infrastructure. And we also added this can both cause a short-term waste and a long-term negative impact for the stakeholders. What about differences between process and technical debt? Well, we found a little bit some similarities and some differences. Accumulation, how it's accumulated. Both of them are actually, like you can imagine, the focus on short-term leads to long-term consequences. As I mentioned, process debt also generates an initial waste, which is less emphasized in the technical debt, less reported. What about the variables for thinking about this, the assessment of the debt? Principal and interest variables can be used in both systems. The value, though, the value of the process, as I mentioned, it's something newer that hasn't been that much discuss in technical debt literature. What about the causes? We found quite a few similarities. One main cause of suboptimal prioritization is a common cause for occurrence of technical and process debt. Process and architectural debt can be similar because we have a design and then an execution. Code is a bit different because you have more like the actual execution. Sorry. We found some differences in the consequences because process debt shows more continuous disturbance for the developers rather than like something that is a bigger issue, like, you know, having a bigger block for a feature or something like that. Although this happens also for technical debt, I think process debt, it's even more about this continuous disturbance. Process debt is also less measurable, at least in technical debt. You have the code that you can analyze. We have some instruments for that. For the process, it's way more difficult to actually measure what people do. We have a host of different tools and so on. Process debt needs additional categorization for that is because there are many activities that are involved in process debt, so it's not maybe as simple in a sense as technical debt to categorize them. Then we found that documentation is similar, but we don't have the same thing as comments and code documentation debt in for process debt. Okay, so that's it. I hope you enjoyed our talk. If you have any questions or are interested in this topic, just reach out. Have a nice conference. Bye.